In most cases, our end stations are going to be receiving their IP addresses from a DHCP server. However, we do have the option of configuring our switches and our router interfaces to be configured via DHCP as well. And we can accomplish this with the IP address DHCP command in interface configuration mode. So if you are expecting a router interface or a switch to receive an IP address via DHCP and it's not, you'll want to double check that this command is configured on that particular router interface. However, let's think about it from a client standpoint in this case. Let's say your multi-layer switch, your router, is acting as a DHCP server for your clients. What is something you have to look out for? Well, one thing is we have to have a pool. That's a big thing. We need a pool that is going to be handing out IP addresses for those particular devices in that subnet. It's going to have to hand out a default gateway. If the default gateway is not handed out, then clients won't be able to leave their subnet. So that default gateway address has to be a correct address within that network, that pool we're handing out addresses for. We'll have to throw in some DNS addresses in there as well for name resolution purposes so the clients know who to contact for name resolution. But one of the most often things that are overlooked is that the router has to have an appropriate IP address on the interface that it's going to be handing out addresses from that pool. So the router receives that DHCP discover message on an interface. If there is no pool available for the IP address that router interface is part of, then it's not going to hand out addresses from the pool. And it's obvious why. It's because that router has to be in the same subnet as the addresses it's handing out for. If it's not, then how are devices in that subnet going to communicate with that router interface? They can't. They can't. Let's look at an example of this. If we go over to PC1 right now, PC1's complaining they can't reach the internet. All right, let's ping. 192.0.2.1, bam, we can't reach the internet. So we've confirmed the problem in this particular case. Let's check its IP address. And immediately, I can see we have an issue with connectivity between PC1 and the DHCP server. In this case, DSW1 is the DHCP server. So since we weren't able to reach the DHCP server, we have automatically configured an IP address on this interface. 169.254 with a /16 mask. That's one of those APIPA addresses. So this is a good sign that either you can't reach the DHCP server because of some issue between PC1 and the default gateway, or it could mean that the DHCP server is configured incorrectly. So let's examine DHCP as being a possible issue here. If we open up Wireshark, which I love showing everybody. So let's do that. And let's start a capture here. We're going to start a capture. Didn't specify an interface. All right, let's start a capture on PC1 interface. But what do I want to capture? I just want to capture boot P. That's it, just boot P. No, boot P. There we go. There's a DHCP discover message being sent. There's another DHCP discover message being sent. They are going unanswered. They are going unanswered. Which means there's no device in the local network within that broadcast domain that is responding to these DHCP discover messages. We know that DSW1 is the DHCP server. So let's issue the debug IP DHCP server and packet command. Let's take a look at packet. Oh, and we'll also take a look at events. Packets and events. Let's see what happens here. Let's see if we're receiving anything. I think PC1's going to wait a little bit before it sends some more. So let's go ahead and just disable PC1's interface. Let's re-enable PC1's interface. Let's start our capture again. All right. We should see some, there you go, DHCP discover message being sent. Let's look at DSW1. There we go. All right, you all to shut off our debugs. We can see here that we did receive a DHCP discover message, which means that we have connectivity from the client up to the default gateway. We were able to successfully confirm that there's no problem right now between PC1 and the default gateway. So we've just eliminated VLANs as potentially being the problem, trunks being the problem, because that DHCP discover broadcast message made it all the way to the DHCP server. So it appears that we have an issue with DHCP. And if you look down here, it says there's no address pool for 10.1.1.129. Wait a second. Let's look at our topology. I don't even have that as a subnet in my topology. So this particular IP address is completely out of range. PC1 is part of VLAN 10, so the SVI for VLAN 10 is interface VLAN 10. So let's look at that. Show IP interface for VLAN 10. Oh yeah, look at that. The IP address on that interface is incorrect. Let's examine our DHCP pool. Show IP DHCP pool. By looking at the output of this DHCP pool, you can see the pool is VLAN 10 10.1.1.0/26 is 10.1.1.29 in 10.1.1.0/26? Nope. No, it's not at all. It's not at all. Therefore, we definitely have an issue on our hands, because when the DHCP discover message is received, as we saw earlier from the debug message, there is no address pool that this IP address falls within. Therefore, it can't hand out IP addresses from this particular pool that we have. We need to fix the problem. So what is the problem? The problem is that the interface isn't addressed correctly. So if we do show run interface VLAN 10, we definitely have the wrong IP address configured. So we'll type in configure terminal, interface VLAN 10, and the IP address is supposed to be 10.1.1.1, 255.255.255.192. As soon as we hit enter, let's go back to PC1. All right, give it a few moments here. Give it a few moments. Maybe we could speed it up by disabling the interface. Okay. We'll re-enable it, and then we'll start a packet capture right away. Hopefully we didn't miss it. Oh, we did miss it. We missed it. We missed it, but we would have had our DHCP discover, offer, request, acknowledge. There's the acknowledgement right there. So let's take a look now at the IP address on PC1. And we can see it right there. It received its IP address successfully, 10.1.1.10/26, 10.1.1.1. So what was the problem? They said they couldn't access the internet, so ping 192.0.2.1. And they can access the internet now.